Hi, we are from Group E, and today we are going to present our mini project Cryptography. Our given topic is digital image encryption's algorithm based on Charles and improved DES, written by Zhang Yunpeng, Zai Zhenjun, Liu Wei, Nie Xuan, Chao Suiping, and Daiwei Di. This article is published on proceeding of the 2009 IEEE International Conference on System, Means, and Cybernetics San Antonio, TX, USA on October 2009 from page 480 to 485.
This article discusses the significance of digital image in Internet information transmission, constituting 70% of the data. Traditional encryption algorithms like DES and IDES are deemed unsuitable for image encryption due to the unique characteristic of image data. Choice, recognized for its randomness and characteristics like noise sensitivity, initial unpredictability, ergodicity, and divergence index, is proposed as a natural encryption tool, particularly for two-dimensional image encryption. The integration of choice into digital image encryption began in 1997 with Friedrich. Despite the advantages of chaotic image key encryption, such as simplicity, robustness, and faster encryption, challenges like limited precision, short cycles, and difficulties in measuring password formation and cycle persist. The article emphasized the immaturity of chaotic encryption technology compared to the traditional methods, calling for further research and improvement. A proposed solution combines chaotic encryption with traditional DES encryption for digital image encryption. The method is analyzed for its pros and cons, and improvements are suggested to address its limitations. The goal is to leverage the strength of chaotic and DES encryption, creating a complementary and effective approach to overcome their respective shortcomings.
Moving on to the objectives of the paper. The first objective is to introduce a new encryption algorithm that combines chaotic encryption technologies with traditional encryption technologies. This combination is intended to enhance the overall security. The second objective is to analyze the security and complexity of the algorithm. This involves assessing the resistance of the algorithm against various cryptographic attacks. The third objective is to address the deficiencies of chaos-based image encryption techniques and propose improvement to the algorithm. The fourth objective is to test the improvement encryption algorithm through decryption tests, sensitivity tests, statistical analysis, and relevance of adjacent pixels. The fifth objective is to conclude the combinations of chaotic and traditional encryption technologies provides better security for digital image decryptions.
So let's see explanation of proposed technique. First of all, digital image encryption. Digital image encryption is a process of securing digital images to prevent unauthorized access, modification, or transmission. Encryption algorithms use mathematical techniques to transform the original image into ciphered form that can be only decrypted by those with proper keys. Other than that, we can see chaos-based encryption. Chaos theory involves deterministic systems that appear random and sensitive dependence on initial conditions. Chaos-based encryption leverages chaotic maps or chaotic systems to introduce randomness into the encryption process and enhancing security. Other than that, we can see improved DES, which is data encryption standard. DES is a symmetric key algorithm widely used for data encryption. Improved DES implies enhancement that made into the original DES algorithm to address its vulnerabilities. This may include increased key length, improved substitution permutation networks, or other modification to strengthen the security. Now let's dive into demonstration of proposed technique. Number 1 is key generation. Generate a secret key for the encryption process. This key will be a combination of chaotic map, generated values, and other secure key generation techniques. Other than that, we can see chaos-based transformation. Use a chaotic map such as logistic map or Hanon map to introduce chaos into the image. This chaotic transformation enhances the diffusion properties of the encryption process. Number 3 is initial permutation, which is IP. Apply the initial permutation using the improved DES algorithm. This step rearranges the bits of the image according to a specific permutation table.
Hi, I'm Chan. I'm going to talk about the difference between the chaotic encryption technology and the traditional encryption technology. So for the chaotic encryption technology, it uses the chaotic theory to encrypt the data. So there's a chaotic map. There's a four kind of map over there. Because it's a graph, it's very have a high sensitivity to the initial conditions because it uses the iterations. A wrong guess of the initial conditions would affect the whole graph, so it will be not decrypted. It's very random, it has a non-linear behavior, it's very hard to predict the initial conditions. The chaotic encryption technology has a higher intensity of computational and very less efficiency compared to the traditional encryption technology. So for the traditional encryption technology, as we know, is the RSA AES. They use the predefined keys that share among the parties. They also use generators to create many randomness keys. Even though it's very high efficiency, but it's not quite safe as the chaotic encryption technology. So this is the deciphering test for both of the encryptions. So from as you can see, the left side is the improved encryptions and the right hand side is the original encryptions. So they really look alike and the result is look the same. They don't have much difference. Now for the sensitivity test. As you can see from the left hand side is the improved encryption and for the right hand side is the original ones. So the sensitivity of the both of the encryptions are very sensitive, even though it's only have the different value in the 8 decimal points. So after decrypting, the information cannot be seen from the pictures for both. Now we're going to talk about the statistical analysis. As mentioned just now, the left hand side is the improved encryptions and the right hand side is the original encryptions. So as you can see there, the original histogram encryption is not really even distributed. Meanwhile, the new technology provided is more uniform distributed throughout the image pixel value. Lastly, I will be talking about the relevance of the adjacent pixel. We randomly selecting pairs of adjacent pixel, then substituting into the formula as you've seen over there to find the coefficient adjacent pixel. If the coefficient adjacent pixel is really nearly to 0, then it's very well encrypted. Meanwhile, if very close to 1, then the split image are very highly relevant. As you can see over the result there, the result of the improved encryption and the original. The results show that the correction coefficient of the improved encryption is much more lower than the traditional.
Chaotic encryption technology relies on the chaotic theory. It is encryption that relies on highly sensitivity to initial condition. The randomness and the nonlinear behavior makes it hard for attacker to predict. It is also highly intensive computational but has less efficiency. It is different from the traditional encryption technology. It has less proficiency but harder to decrypt it. Signal used in the chaotic encrypted signals the mapping of the chaotic sequence under a certain initial value and 50 by the interception of a pseudo-random sequence. The process involves encryption product, interception, and such as model for computing. Chaos is different from the original sequence, thus confidentiality has been strengthened. Secondly, in the channel for transmission for the test was obtained after 2 encryption. A combination of both can confirm the literature raised in the chaotic system of identification and the initial value determined by the decipher ways to enhance confidentiality. The use of the signal chaotic signal of the extreme sensitivity of the initial and long-term unpredictability causes chaos to be encrypted signal as DES encryption level of input. In doing so, we will find the corresponding explicit does not exist between the DES algorithm, makes the input and the output of the text has overcome the DES key, and weak in the semi-weak key weakness. Thus, it can resist the current attack on the most effective DES patrilineal analysis and improve the confidentiality.
Conclusion: The integration of chaotic encryption technology with traditional encryption method demonstrate improved confidentiality compared to using either technology in isolation. The combined approach acknowledges and utilizes the strength of both chaotic encryption and traditional techniques, effectively addressing and mitigating the disadvantage inherent in each. The project use of chaotic mechanism contributes to the advancement in traditional encryption technique, highlighting the innovative potential of leveraging chaos in achieving improved security. The fusion of chaotic encryption and traditional method provide a synergistic solution, demonstrating the importance of exploring hybrid encryption approach to meet the evolving challenge of maintaining technological confidentiality.